Good morning. Welcome to this ongoing online course on engineering and architectural graphics part 2, where we are discussing about isometric projections. In the past lectures of this week, we have seen the fundamentals of isometric projection and we have been practicing the isometric projection for different objects. So, we have already seen how the projections for polygons will come up, where only straight line polygons are there. Then we moved on to curved surfaces, and then we saw how the projections of straight prisms are going to be. Now, today we are going to see how the projections of straight pyramids are going to be drawn in isometric. Now, before we do that, for this entire week I have been repeating the fundamentals of isometric projection, which I will do again today, because this is something that always yields us the answers and we have to keep it in mind. So, the lines parallel to each other in the object will remain parallel in the isometric projection. The lines parallel to the axis will remain parallel to the axis, the x, y and z axis. So, these are the isometric lines. All other projection points are arrived at by arriving at their parallel distances, which is what we do when we make these reference rectangles. Now, this is exactly, now in pyramid you will realize, and you have already seen, in pyramids there are no parallel lines, unlike straight prisms. So, straight prisms, there were rectangles, we had these parallel lines of height and in the base as well, but in pyramids you will not have any single line which is parallel. All of those lines are non-isometric. Now, how do we draw that? This is what we are going to learn today. So, let us start by looking at this triangle base pyramid. Okay? This is what we are going to draw here. Now, how do we draw that? There are multiple ways in which we can possibly do that. Now, one way is, I will change the ink color so that we know that this is actually not these are just the reference rectangles. One way is to make the reference rectangles, right, and this is the most common way. So, what I will do is, in the elevation I draw a rectangle, okay. In the elevation we draw a rectangle. In the plan also we draw a rectangle. Now, this is the apex. We can have the distances of the apex in both the plan and in the elevation. This is what we are going to draw when we are going to convert it into an isometric projection. So, let us start by drawing this plan. So, assuming that this is kept in HP, this is, say, the base. Okay. So, this is the triangle. We got these 3 points. Now, I am not darkening them right now, I am just drawing dotted lines because we do not know what will be seen. Now, another point which we have to locate right in the base is where the apex is, if it was in the base, if it was flat. So, what we do here is we have this distance. So, we will mark this distance. This is where the apex is going to come at a height. Now, we will draw this. This is in front view. So, say this is what we will see here, right. Okay, so approximately here. Now, I am not, what I have done is I have just raised. So, this was the rectangle which we saw in the front, and this is the rectangle I drew right behind it. Now, if this is the line. So, if this line is giving us the projection of this apex, there is going to be a line parallel in the top as well, and this point actually will be the point right above this apex in the bottom, and this will actually be the apex O for this pyramid, right. And this is, say, A, B and C, and this is O. We have arrived at all the vertices of this pyramid, and all that we need to do now is join them. AO, OC, OB might not be as visible, but let us see, AC, and then we have this dotted line at the back. This is what the pyramid is going to be. Okay. This is how it looks like. It is very simple again. There is not a single line which is isometric except for this line, which, okay, by mistake I have taken as AB, but this is actually AC here. Maybe I will write ABC. This was the only one which was parallel, which was an isometric line. None of the other was an isometric line. So, what we did? We arrived at the other points by taking their parallel distances. We enclosed these in the rectangles. We arrived at these distances, the apex and all other points, and then we just joined that. This is what we are going to do when we are going to draw the pyramids. Now, suppose the pyramid, so this one is a square base pyramid. We will do exactly the same process here, but as you can see, this is inclined at 45 degree. Now, what did we do with a square which was inclined is the same thing that we are going to do here, right. So, what do we do here? We enclose it, in a square here. We have another rectangle where we enclose the front view. Okay. So, we get this apex in this one. We know that this apex is at the intersection, and now we will draw very simply. So, I would rather draw it in another color and then we would finalize the last one. Okay. So, we draw this reference square in the base. Okay. This is what we have. Now, I mark these points 1, 2, 3 and 4, and we join this. These are all construction lines. Now, we also have the intersection of this, above which is the apex. Now, what I can do possibly is, I know what is the height of this. From here I can also draw the height and I can arrive at the apex, or what I can do is, I have this rectangle, I can make this rectangle here, okay, at the center, and this one I can assume, or I could also do this, that I can make a rectangle here, make another one, parallel line here, intersect and arrive at this apex. Whichever way I do, simply because I know that this is a right pyramid, this apex is, this axis is perpendicular, I will get it parallel to z axis. That's what we know. So, if any line is parallel to the axis, it will remain parallel to the axis, the 3 axis. So, which is what we exploited and we got this point. So, now we will finalize the projection here. So, this is O, and if we see it here, A, B, C and D, these are the 4 points, and this is O. Now, we can join AO, AB, AC and AD, and then this is the base, this will be the dotted one, and then we can just darken it. This is the final object which we are going to get. The process remains exactly the same. See, the intent of me doing all these exercises here repeatedly is just to make you familiar with the process. The process remains the same, and once you have totally understood the process, you can draw any object, okay, literally any object, whichever is given to you, whatever condition it is given to you. All you will do is, you will look for the references, you will look for the isometric lines, you will look for the references for non-isometric lines, and you will be able to draw anything that's given to you. Let us take another example. Now, this is the same pyramid as the previous one. This is exactly the same as we saw here, but the only thing is that it is now kept in such a way that its axis is perpendicular to VP and parallel to the HP. This is what we are going to be drawing. Now, here what we will do is we will start with drawing the front elevation first. So, I will enclose it in this reference rectangle, because you can see here clearly that none of the sides is parallel to the axis. So, there is no isometric line here. So, we will arrive at this, and then we can also arrive at this apex where it projects and meets in the base where the axis is going to pass. So, I will draw this. Now, we have, okay, so approximately this. Now, say this is A, B, say C and D here, okay. And if I join these, this is what I am going to get as the base, okay. And if we join these, the intersection is where the apex is going to be. Now, we know that this axis, which is this, is actually parallel to HP and perpendicular to VP. So, what we will actually have is that this axis is going to be parallel. This is actually parallel to one of the axes. This axis of the object is parallel to one of the axes of isometric projection. So, this is where this axis is going to be, and we can cut the height whatever it is here, and this actually will be our O. So, we have this A, B, C and D, and this is the O. Simply we have arrived at that. The other way was that we could have drawn the entire rectangle here exactly at the same place, and then we could have arrived at the same projections and the projection of apex here. We would have arrived at the same point O. You could use any method and you will actually be arriving at the same figure, okay. So, now we have this O, C, B, A and D, and now we will join. So, we will first join the farthest one. So, we might not be able to see the ones in the middle. So, this will actually be a hidden line, okay. Now, we have this AO, DO, AD, AB, BC is hidden and DC is hidden, and this is where the axis passes, right. So, we know that this axis was passing through this. Now, we saw that this square was also slightly rotated when it was placed in the VP, yet we could very conveniently draw. All we have to do is arrive at this reference, and that is what we have done. So, we have this final object which you can draw. Now, one thing which you can do if you want to just improve how to draw these isometric projections is you can take a grid. So, what you see here, this grid, these grids which I use, this is what I have used. So, there are isometric grid pads available in the market. You can take that, or there are big sheets like graph papers which are isometric grid papers, and you can directly draw on these graph papers. You can use either one of these, and you can practice. As much as you practice, the better you will be. So, that is what you should be doing, and all the steps that I am explaining here, you can actually practice on those sheets by drawing. Or if you have a digipad like this, the one that I am using, you can also use it in you can also practice on these digipads. Now, this is again this example where I have a pentagonal pyramid, again a straight pyramid, the same steps, the same process to be followed. So, what do we do first? We enclose this pentagon in a rectangle, a reference rectangle, and we arrive at these 5 points, and we also arrive at this point beneath the apex, okay. And now we know that this is in the base. So, what we will do? We will simply make this base. So, we will arrive at these points. right. So, this is A, B, C, D and E, and now we also have this point O. So, this is a line passing through D, and on this line we would know that out of this distance which we measured, where this O is going to come. So, we know this O in the base, and now we will take, because this axis is perpendicular to HB. So, we know that it is parallel to Z axis. On this we will take certain height, whatever the height of it is, O dash, and these are all the points of this pyramid. Very simple. All we did was have a reference in the bottom. Unlike prisms, we do not have to take the rectangle up in the height, not necessary. All we have to do is arrive at this apex point here, and then we can finalize the object. So, this is OA, this is OB, this is OE. Maybe it might become visible or it might not, totally depends upon the drawing. Okay. So, what we have drawn here is again the same procedure arrived at the base with the help of this reference rectangle, yeah, and then we arrive at rest of the points. This is what we have done. Final figure A, B, C, D and E, and this is O dash, and then you can also mark the axis. So, you already know how to mark the axis. There are different line type to be used. This is our point O in the base. Very simple. I hope you are able to understand the steps here. Identify if there is an isometric line, which is what it was, AB, and the reference rectangle for rest of the non-isometric lines. We did this. We located these points on these the isometric lines which we drew as reference, and then we arrived at the rest of the points and we just connected them. It is a very simple process, and I am sure all of you are understanding it well, but I just repeat that you have to practice more and more here. Again, this is the same pentagonal pyramid, similar pentagonal pyramid, a different height and this pentagon here. Now, you know very clearly where do we start from. We start from this rectangle and we arrive at these points here. So, this is the pentagon which is going to be arrived at first, and then we would know where this O is, take the height, join the points very conveniently, and you arrive at this pentagonal pyramid where this side, this is the isometric line, the only isometric line, and this axis which is joining this O dash to O in the bottom. So, these are the only two isometric lines which we have. Rest all of them are non-isometric lines, but we very conveniently arrive them with the help of this reference rectangle, right. This is a hexagonal pyramid. Again, it is very simple. You can arrive at that. So, here it is better because we have 1, 2 and 3 isometric lines. The other one we will create, which is this reference. We already know what this point is going to be. So, let us quickly draw this. Okay. So, let us see this B, C, A, F, E and D. Okay. So, these are the points which you would have. This is where the apex O in the bottom is going to come, and since it is a straight pyramid, we will have it here, and that is what we are going to have as a hexagonal pyramid. You can finalize it, but the shape is very easy to arrive simply because we had these 3 isometric lines here, and you can see that it is much easier to draw on these isometric lines, and the fundamentals will always hold good. They are parallel to each other, which is what we saw. We can simply make the rectangle and arrive at these reference lines. If I join this, this is going to be parallel to this, which it will be. So, if I join these two, this is going to be parallel to these. So, if you look at the reference figure also, and if you see that there are certain parallel lines or lines which are parallel to the axis, they must appear so in the final isometric projection as well. There should not be any deviation from that fact that the parallel line now does not appear parallel. In case that is so, you automatically know that there is some problem which is there. Now, this same figure could be kept in some other manner. It could be that we have this hexagon in the VP and the pyramid is perpendicular to the VP. So, what we will do is simply we will arrive at the front elevation of this hexagon. This is the base. Okay. I am darkening it here, but no, we have to first draw it in light, and then we arrive at this apex. You draw it because this is a right angled prism pyramid. So, we arrive at the O dash and then you just join. It is very simple, actually it is very simple, and now this is your axis and this is your pyramid, which is what you are going to be drawing. It could be kept in any manner. Now, suppose any of this pyramids was inclined, where do we start with now? In case it becomes inclined, the axis is not an isometric line, the plane itself is not an isometric line. So, very simply what we are going to do in that case, for example, there was a hexagonal pyramid which is inclined. So, we will first draw the base, forget about the rest of the pyramid, just draw the base. So, what we will do is, again just as we do all the time, we will have this reference. This is the reference rectangle for this hexagon. Okay. We will arrive at the points of the hexagon. This is how probably the hexagon might look when it is drawn on this one, right. And now we will have the point for we will have the reference rectangle for the apex as well. So, this apex might be, of course, we know that this is in the bottom, this is emanating from this one, but how do we derive the angle? So, that angle might be derived, and for that a rectangle in the base might be there. So, what we will probably do is that we might have, or if we project it down, we might actually have a rectangle which is emanating in this manner. So, there is a rectangle which contains this axis, and this is going to be the axis. And once we have determined the axis, okay, this should not have been dark, and then we just connect all of these. And what we will then do is, from this apex we will get the pyramid. So, this is slightly tilted, this is inclined, but how do we arrive at this one is by drawing this rectangle. So, what you see here, first we drew this rectangle which was containing the base, this was slightly inclined if you can see, and then we also drew this rectangle which will contain the axis of pyramid, which is again inclined. So, what we have done here is that we have this rectangle which is inclined. So, we will derive the reference rectangle, draw it accordingly, and then we will place the axis in it, axis of the pyramid in it. This is how we can draw the inclined pyramid also, any object for that matter, inclined objects. This is how we are going to derive the isometric projections of the pyramids, right angled pyramids. So, each of these pyramids that we have discussed here, whether it is pentagonal pyramid or it is square base pyramid, whichever way it might be kept. Now, here in this one, it could have very well been inclined. So, instead of being perpendicular to VP, what if it was just touching the base? We would have managed to draw the projections accordingly. But remember, whenever we are drawing isometric projections, we need to have the orthographic projections in place to arrive at that. And that is the beauty, that is the biggest advantage of orthographic projection, that just by knowing how this object is kept, you can draw orthographic projections. In isometric projections, you can still draw, but it will be very difficult to directly derive it in the isometric projection. So, for isometric projection, we will still have to depend upon orthographic projection, but it makes it much more visible. So, if you look at this drawing and this drawing, isn't this drawing much easier to understand, to comprehend that, oh, this is what we are talking about, this is how the pyramid is kept. But in this one, it might be slightly difficult for some people to understand how this pyramid is kept just with the help of this orthographic projection. So, I hope with this you have understood how to draw the orthographic projections of pyramids, right angled pyramids. That is all in the lecture today. We will see you again tomorrow in the next lecture, where we will take up another type of object, another type of 3D object, and see how isometric projections of those objects have to be drawn. So, thank you very much for joining me here today. Bye-bye.